All right, for this section, we're going to be solving literal equations, okay? Which means that we're going to be solving for a specific letter, leaving that letter by itself. So whatever's happening to that letter, we need to do the opposite in the opposite order to get it over there. So it's very similar to what we've always been doing. So here we're leaving m by itself, okay? M by itself. So m is multiplying with 4 and then subtracting with 3m. So the last thing that would react with the m is the minus 3n. So we're going to get rid of that first. So we're going to add 3n to both sides. This will cancel the 3n. And now you're left with 4m equals 8 plus 3n. Then to leave the m by itself, you have to do the opposite of what the 4 is doing. The 4 is multiplying, so we're going to divide. So we're going to divide by 4. Okay, that's going to cancel this. 4. Divide by 4, and we are done. What does m equal? M equals 8 plus 3n divided by 4. So that's the correct answer. If you wanted to simplify it a little bit extra, you could divide the 8 by the 4 and get 2, and then leave the 3 over 4 multiplying with the n. Okay, this is the correct answer. This one's a more simplified answer. This is probably what you'd find at the end result of the ELC. Now we're going to be doing this. We're solving for x in this one. Now, when you run into a problem like this, what you want to do first is make sure all the things with the letter you're looking for are all on the same side. We're looking for x. Anything with x has to be on the left. Anything that doesn't have x, I need it on the right. Now, when you move an entire term from one side to the other, okay, when you cross this line, the sign is going to change. So this 3x is just going to come down. So it's going to stay 3x. When I move this xz to the other side, it's going to become a minus xz. Then this minus 2y, I'm going to move it to this side of the equal sign, and it's going to be a positive 2y, which is just 2y. The plus 5 is going to come down. I haven't done anything with it. So that's your first task. Make sure everything with the same letter is on the same side. So what we're going to be doing here is reverse distributive problem. Okay, so we're going to divide something out of both of these questions, both of these terms. We're going to divide the x out. So if I divide both of these x out and take them away, I'm going to have x, and then that's going to be 3, and that's going to be minus z. You can check. If I distribute this x, it's going to make that. So I reverse the distribution. Okay? And this still equals 2y plus 5. Then, now why did I do this? Because I couldn't combine like terms, but I still have to get rid of that x. Then we're going to get rid of 3 minus z. X is multiplying with this entire thing, 3 minus z. So if I divide by 3 minus z, that'll cancel it. Divide by 3 minus z, and there's our final answer. X is all by itself, and it equals 2y, I don't know why I'm writing 3, 2y plus 5 divided by 3 minus z. All right? Now we're going to this one here. We'll do this one, and then we'll work on that equation that Hector's. All right, so let's do this one. This one's slightly different, very similar start. Okay, here we're solving for the letter D. So D equals. So here we're going to put everything with the letter D on this side. So D comes down here. 3D is going to come over here and become minus 3D, and then the 5C is going to become minus 5C, and the minus 1 comes down, minus 1. So it's very similar so far. But look at here. These can combine like terms, right? This is easy. D minus 3D leaves me with, so this can combine like terms, and we're going to make minus 2 D, because 1 minus 3 leaves you with negative 2, equals negative 5C minus 1. So now we just have to leave the letter D by itself. So we're going to be dividing by negative 2 and dividing by negative 2. So now we know that the letter D equals negative 5C minus 1 divided by negative 2. All right, not that bad. Now it's a negative divided by negative, so you could change the signs of both, but you don't have to. You can leave it like that. All right, next. Okay, this is a mixture problem, but a different type. We've done mixture problems before. So here, okay, they give you the final result. Hector needs this. This is what he needs. He needs 160 milliliters of 40% solution. What he has is a 25% solution and a 50% solution. How much of each does he need to mix to get what he needs, which is that? So that's what we're going to figure out. All right, so I'm going to move it to the left. We don't need to read Hector. So what we have is this, 160 milliliters of 40%. So we know that the end result is 40% of 160 milliliter solution. Okay, so we know that those two are going together. Now the other ones we don't know are 25%. We don't know how much we have of that, right? And we also do not know how much of the 50 we're going to have. Okay? So that's also a mystery. Okay? Now the thing is, I don't want to use a different letter because then we'll have to, it'll make it very, very difficult to solve this. I still want to use X. So X plus something equals 160. So I know that X plus something, I don't know what it is, I'm going to put a question mark right here, equals 160. Okay? So if I want to use X to represent this, I have to move the X to the other side. So now, what I'm looking for is 160 minus X. Okay? So 160 minus X goes here. Now, that was the explanation of why I chose that. But what you're really doing in this problem is they're going to give you the total. So that goes to the end. So these two numbers are going at the end. They gave me both. Here, they only gave me the percent, but they didn't give me the amounts. So X and the total amount minus X goes here. You could flip-flop these. They don't really belong in those situations. So you could write 160 minus X here and X over here, and it'll still give you the same solution. Okay? So there's the setup. All right? Now we're going to solve the problem. We're going to multiply 25 times X, which gives us 25X. We are going to multiply 50 times 160. That gives us 8,000. 50 times minus X gives me minus 50X. And 40 times 16 is 6,400. Okay? Now we can combine like terms. I see two terms that we can combine. Okay? So we can combine this one with this one. And that's going to give us negative 25X. 8,000 is going to come down. Now it's just a positive 8,000 like this instead of the plus sign. Equals 6,400. Now we're solving a two-step equation. So we're going to subtract 8,000 from both sides. We're going to subtract 8,000 from both sides. And now we have negative 25X equals negative 1,600. Then we're going to divide by negative 25 on both sides. Negative divided by negative is going to make a positive. So X is going to equal 64. Okay? So X is 64. So how much of this solution do I need? Well, I need 64 of it. Okay? What about this one? How much do I need this one? Whatever 160 minus 64 is how much I need of this. Okay, so of the 50% solution, I need 96 milliliters. This one I need 64 milliliters, and it will make an exact 40% solution with 160 milliliters. Boom. Okay? Now let's go to here, down below here. Okay. So is this linear or not? Now the book describes this as if you can make it into standard form, then it is a linear function. Okay, which means standard form is ax plus by equals c. Okay. Let's see what the problem is they gave us here. Let me see, I had it written here. Okay, so it goes, so I have to move the x and the y to one side and leave a variable by itself. So we move the 3x to this side, and now it reads 3x positive y equals 4. So that makes it linear, because you can do it. Okay? Over here, if you try to do it, it will not work. Okay? You won't be able to make it like that. I have x and y all on one side already, and it still doesn't look like that, so it's going to be nonlinear. Okay? The way that I like to describe it at a glance is the same thing happening to x every single time you do the problem? Okay? So y is by itself, which is what I want, is the same thing happening to x every single time. Well, here we're multiplying by -3, and then we're going to combine the 4. Yeah, that's going to happen no matter what, when I put the x here. Now here, if x is 1, okay, x is subtracting with 6, right? So 6 minus x, or 6 minus 1. And the y is there too, which makes it weird, right? Because I can't get rid of the y. I would leave it like this. Like I would take the x's out, and I would leave it like x, 6 minus y, reverse distributive, x equals 4 over 6 minus y, or actually, no, I'll just move the x to the other side. So 6 minus y equals 4 over x, okay? And then 6 goes over here. It's a lot of extra stuff. I don't like the way that looks. Now, x, the same thing is not happening to x every single time. Okay? It's not. Because if I put 2 in here, now it's 12 minus whatever's going on with that. So it changes. Another form is changing every single time you do this. It's not consistent. It's not going to make a very nice straight line. Okay? So this is a no. It is non-linear. Okay? So for me, I can look at a glance and notice it because I see that it's not going to be consistent. Here, because what you're allowed to do with x is you're allowed to add, subtract, multiply, and divide any number. Now, if you're doing that with x, that makes it non-linear. Like if I write x squared, x is not being multiplied by the same number every single time because every time I change x, it's squaring, multiplying with itself a different number. So it's going to change. Seeing as it changes every single time I change the x, it's going to be non-linear because it's not consistent line. Another way that they talked about doing this is making a chart, which we're going to do something similar over here. Here they want you to use the x and y intercept to graph this. Now, how do you find the intercept? Okay, the y-intercept, how do you find the y-intercept? Where it crosses this? Well, just so you know, when it crosses this, x equals 0. When you're looking for the x-intercept, meaning this right here, y has to equal 0. Okay? So let's find the x-intercept. The y-intercept. If I'm looking for the y-intercept, x has to be 0. So 2 times 0 is 0, so that's no longer there. So now it just says 4y equals 6. Divide by 4 on both sides, y equals 4. So here's my y-intercept. Okay? Now if I'm looking for the x-intercept, y equals 0. Okay? So this is 0. So now I'm left with just this. 2x equals 16. Divide by 2 on both sides, x equals 8. So I didn't make enough lines. 4, 5, 6, 7, 8. And there you go. I only need 2 lines to graph a straight line. The other recommendation they had, I think for this one, was making a chart. Let me see if they asked me to make a chart for this one. No, they asked me to make a chart for this one. So this is using the x and y intercept to graph. The thing is, the x and y intercept is not always a whole number, so it's not used very often. Here we go. So that method can be used if it's going to be, if both numbers are going to be whole numbers. Okay, so here we go. Graph. Now you should know how to graph this by now. This is slope intercept point. Now what they said is make a chart. Okay. Now if you're making a chart and you're multiplying with 1/3, you have to use multiples of 3, so then they come out to whole numbers, your answers. So we'll use 3, 6, 9 as the chart. So 3 times 1/3 is 1 plus 2 equals 3. 6 in here, 6 times 1/3 is 2. 2 plus 2 is 4. 9 in here, 9 times 1/3 is 3. 3 plus 2 is 5. Okay, these are going up by 3. And these are going up by 1. Okay, which means it's linear. That automatically means it's linear because 3/1 and 3/1, that's going to make the same fraction. So now you have points. So you just graph them. 3, 3, 3, 3, 6, 4, 1, 2, 3, 4, 5, 6, and then 4, that's over here, and then so on and so forth. You can also put 0 in this equation. That's a good one. 0, if you put 0 in here, you're going to get 0 plus 2, which is 2. So when you put 0, 2, there's the other one. So here's your line. Remember, you only need 2 to graph, so you only have to do 2 steps to do a graph. And you can choose 0. So that's a good idea too. All right, the other method of graphing is using the y-intercept and the slope, okay, which is a method that I've taught to many of you, so it should be the easier method. Here's the y-intercept. So you start here, and here's your rise over run slope. So you go up 1, go to the right 3. Done. Okay. And then let me see what else there is. That is it. Video done.